With this lesson, I am going to go over some example problems for lesson 6.6. So lesson 6.6 talks about double angle formulas and half angle formulas. When we say double angle formula, this is very important. Sine of 2 theta can be calculated by multiplying 2 times sine of the angle times the cosine of angle. So similarly, cosine of 2 theta will be calculated by cosine squared theta minus sine squared theta. So these two angles are called double angle formulas, and they're very important. Half angle formulas are when you have the alpha is being the main angle, and if you need just a sine of the half of the angle, half alpha over 2, it will be equal to plus and minus square root 1 minus cosine alpha over 2. Cosine alpha over 2 is equal to, again, plus and minus square root of 1 plus cosine alpha over 2. And tangent alpha can be calculated by dividing these two, and then it will simplify to this formula. So I grabbed some of the questions from your 6.6 My MATLAB homework, and then we're going to try to handle them together. So first question is, sine of theta is given as 6 over 7, and theta is between 0 to pi over 2. That means theta is a quadrant 1 angle. So for quadrant 1, everything is positive, sine is positive, cosine is positive. So we're going to find the exact value for each of the following. So if you look at the part A, if I need to calculate sine of 2 theta, its formula is 2 times sine of theta times cosine of theta. So by looking at this example, 2 times, I have the sine of theta, it's given in the problem 6 over 7, but cosine of theta is missing. So we need to go back to our chapter 4 knowledge. So we need to create this right triangle, theta, and this is the theta, that's a 90-degree angle, so or you can call it x. Its sine value is 6 over 7, so sine means opposite over hypotenuse, so we need to find the adjacent side on this right triangle. So if you do Pythagorean theorem, 49 minus 36 squared is equal to missing side squared. So that is 13, I believe. 13 is equal to a squared. So this missing side will be equal to a square root of 13. Now, if I have the now adjacent side on this right triangle, I can now go ahead and create the cosine value. Because this is a first quadrant angle, cosine value will be still positive. So cosine of this angle will be the adjacent side over the hypotenuse side. Since we found the adjacent side as square root of 13, hypotenuse is still 7. All we have to do is now multiply these numbers. So 2 times 6 is 12. 12 radical 13 over 7 times 7 is 49. This will be the answer for this question. If my MATLAB is giving some spatial directions, you can just manipulate the number further. But as I can see right now, there is nothing I can simplify this fraction. Part B is asking for cosine of 2 theta, which can be calculated by 3 different formulas, but you can definitely use cosine squared theta minus sine squared theta. Now, we already know that cosine value of this angle is square root of 13 over 7, but we need to square this according to the formula. Sine value is given in the problem 6 over 7, and we need to square this before we subtract them. So root 13 squared is just 13, 7 squared is 49, 6 squared is 36, and 7 squared is 49. And when we subtract these two numbers, that's a negative 23 out of 49 is the expected answer for the part B. These two are called the double angle formulas. Now, we're going to actually look at the half angle formulas now. These are the half angle formulas we need for this section. So I am thinking I can just, let's do this. Let's just copy this first and then clear the whole thing. And then Control V now. So I'm gonna now continue with the same problem, but this time we're gonna focus on these two parts, sine theta over 2. So for sine theta over 2, I need to go to the previous page and grab the formula, It's plus or minus. Now, since the theta is already in the first quadrant, when you divide the angle by half, it's going to be still in the first quadrant. So the expected sine value will be here positive. So I'm just going to grab the radical portion, 1 minus cosine of theta over 2. This is the formula I need. Equals radical 1 minus, again, we did this on part A and part B using the right triangle approach. We know that cosine of this angle was square root of 13 over 7. So I'm going to need a square root of 13 over 7 here, but then we're going to have to divide this by 2. Now, without using a calculator, let's try to simplify this math as much as possible. And it also depends on what your MyMathLab requires. If it just requires a decimal answer, you can definitely just enter this to a calculator. But if they just want the answer in terms of radicals, I can change the 1 to a 7 over 7 because that's still a 1. And then when I combine them, that's 7 minus radical 13 over 7 out of 2 and take the square root. So inside of the square root sign, copy the first one, 7 minus radical 13 over 2, and then we're going to multiply it by the reciprocal of the second number, so which is 1/2. And then radical, and then when I multiply this top by 1, it's still 7 minus radical 13 over 2 times 2 is 4. And then the numerator can be written as 7 minus radical 13, and square root of 4 is just 2. I can just leave my answer like this. If my MATLAB wants the decimal corresponding for this number, you can use a calculator and change it to a decimal. And finally, part D, cosine of theta over 2. So from the previous page, this is the formula I need again because theta is in the first quadrant. So when we divide the angle by 2, the angle we get is going to be still in the first quadrant. So its cosine value will be still positive. So all I have to do is copy the square root of 1 plus cosine of theta over 2 portion. Radical 1 plus, and now cosine of theta is root 13 over 7 divided by 2. So by just looking at the pattern here, I feel like I'm going to get the exact same answer as part C, but the sign is going to switch to a plus instead of a minus due to formula, and this is how I can finish part D in this question. So for section 6.6, a very, very, very similar example to what we just finished, but this time cosine value is given a negative number, and then the theta is now between pi over 2 to pi, so theta is an angle in quadrant 2. So in quadrant 2, so for example, in quadrant 2, it might be 100 degrees. So when you divide this by 2, it's going to be 50 degrees, right? The highest number in quadrant 2 is 180 degrees. So when you divide this by 2, it's going to be 90 degrees. So you have to think about these options to think about the sign after these formulas. Anyway, so according to this question, the angle is in the second quadrant. Cosine value is given. So let's work on its sine value first. So this is a double angle case. Sine of 2 theta will be calculated by 2 times sine of theta times cosine of theta. Again, 2 times. According to the question, this is missing, so we have to work little extras to find it. But cosine value of that angle is given as negative root 3 over 3. Now, because this is missing, we will have to create a right triangle. And then this is my theta value here. Its cosine is always adjacent side over hypotenuse. So we're going to apply Pythagorean theorem. So this is 3 squared is 9, and this number squared is just 3. 9 minus 3 is 6. So this must be a square root of 6. So if you confirm the Pythagorean theorem, when you square this number, you get a 6. When you square this number, you get a 3. Add them up 9, take the square root. That's what you're going to get here. And then the sine value of this angle is opposite over hypotenuse. So it's going to be square root of 6 over 3. I just have to think about the sine In the second quadrant, this is where the second quadrant is, and this is the sine axis, and this is the cosine axis. So cosine is a negative number, but sine is still a positive number. So now, when we multiply these three numbers, the result will be a negative number. And then root 3 times root 6 is root 18. So it's 2 times root 18 over 3 times 3 is a 9. I have to simplify this radical further. This is 9 times 2. 9 can go outside as 3. So it's going to be 6 radical 2 over 9. And I can simplify both of these numbers by dividing 3. So it's going to be negative 2 root 2 over 3 is the expected answer for part A here. For part B, for cosine 2 theta, my favorite version of the formula is cosine squared theta minus sine squared theta, but you can use the other versions if you like. So cosine value is given in the problem, that's negative root 3 over 3, but according to the formula, I must square this number. And sine value, I figured this out on my own. Sine value was radical 6 over 3, but I need to square this number. So that's a negative squared is still positive, and then when I square this number, that's a 3. 3 squared is 9. And then when I square this, that's a 6 over 9. When I subtract these two fractions, I get negative 3 out of 9, which can be simplified as negative 1/3. And this is what we're going to get for part B for this question. Now I'm going to do the same thing to open some space here. I am going to first cut this part, clear, and then put it again. Now, for the same question, if we need sine of theta over 2, so as you know, these two are called the half angles. So now I need to look at the slide again, but for half angle formulas. So it's 1 minus cosine alpha over 2 in a radical. 1 minus cosine of theta over 2 in a radical, and I have to think about whether it's going to be a plus or minus. Now, since theta is in a second quadrant angle, when you divide the angle by 2, it will generate a first quadrant angle, so the sine value will be positive, so I don't need a negative here. So we're just going to evaluate this radical 1 minus. Cosine value is given as negative radical 3 over 3 over 2. And then if we keep working here, two negatives, they will create a positive. So instead of 1, I want to write first 3 out of 3 because this is still a 1. And then this changes to a plus, and I get a root 3 over 3 here. And then this whole thing will be divided by 2. Now the denominators are not matching, so I can write it as a one single expression. And then I still need to divide this by 2. So according to the fraction division, copy the first one, multiply it by the reciprocal of the second one. So the expected answer will be radical 3 plus radical 3 over 6. And then even this over 6 is in a radical. So in short, I don't know what version my MATLAB wants, but I can just leave the answer like this. However, if they want the decimal corresponding, you can use calculator to change this to a decimal. So for part D, since we have seen this before, it's just going to be the exact same calculation, but the formula is going to change it to a plus. So I'm going to get the exact same answer, but it's going to be 3 minus radical 3 over 6. And I just have to think about what sign I get here. So this is in a second quadrant, so something like 120 maybe. But when we divide the angle by 2, that's a 60-degree angle, which is in quadrant 1. Quadrant 1 cosine value is still positive, so I don't need a negative before this value. That's how I do the question 2 on the homework. Now, this is question 3 on the homework. So it says using the half angles formula to find the exact value for sine 22.5. So we just have to understand that first, 45 degrees, if you take it, divide it by 2, you get 22.5 degrees here. So here, alpha being 45 degrees and alpha over 2 is equal to the 22.5. So we need sine of alpha over 2 So if you go back to the very first slide that I have here, which has the formulas, sine of alpha over 2 is plus and minus 1 minus cosine alpha over 2 in a radical. So the formula I need is 1 minus cosine alpha over 2 in a radical. And then since 22.5 is a quadrant 1 angle, its sine value will be equal to a positive number, so I don't need a negative here. So this is the formula I need. So for 45 degrees, we know that sine 45 is radical 2 over 2, and cosine 45 is also root 2 over 2. But for this formula, I just need the cosine value. So we're going to go ahead and work on this expression. I need a big radical sign. Formula starts with minus, and then I need cosine of 45, which is root 2 over 2. And then I just have to divide this by 2. Again, just like the previous example, my trick is changing the 1 to 2 out of 2 so the denominators can match. So I can write them as a one single number. So at the top, I can now write them together as 2 minus radical 2 over 2 out of 2. So in the radical, copy the first fraction, which is 2 minus radical 2 over 2, and multiply it by the reciprocal of the other number, which is 1/2. So the top will be 2 minus radical 2, and the bottom will be 2 times 2 is just 4, and I need to take the square root of this number. So again, I don't know what my MATLAB specifies about the answer format, but I will leave this answer. The numerator is 2 minus radical 2, and the denominator is just square root of 4, which will be 2, and this will be the expected answer for sine 22.5. So on the homework, if they ask you to find the sine of this, again, if alpha is 5 pi over 4, which is another famous angle because every time you have a multiples of 45, that is a well-known angle on unit circle. And then 5 pi over 4, actually 5 times 45 degrees, which will be 225 degrees. But here, because sine is an odd function, instead of working on this negative angle, the negative goes to the front. So you can basically just evaluate of negative sine of 5 pi over 8. So you can just do everything for sine 5 pi over 8 first, and then whatever the answer you get, you just have to give them the negative version. So alpha is 5 pi over 4 in this question. And half of this angle is because if you divide 5 pi over 4 by 2, you get 5 pi over 8 because dividing by 2 is multiplying by the reciprocal of 2, multiplying by 1/2, this is what you get. Again, sine of alpha over 2 is the same formula we need. It's 1 minus cosine alpha over 2. So 1 minus cosine of, and in this case, alpha is just 5 pi over 4 divided by 2, and we're going to have to take the radical, and we have to think about the sine. So half of 225 is an angle a little bit over than a 100 degrees, which is in the second quadrant, and second quadrant sine value is still positive, so this will return me a positive answer. So here, 1 minus cosine of 5 pi over 4, again, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. This is the 5 pi over 4. So it's in quadrant 3, both cosine is negative and sine is negative. Okay, so this will be a negative value. And then the reference angle is pi over 4, and cosine pi over 4 is root 2 over 2. We're going to have to divide this by 2, and then we will take the square root. Here, two negatives, they will make a positive, so I get 1 plus radical 2 over 2, and then we're going to have to divide this by 2. If I do some simplification now, I can write the 1 as 2 over 2, which will give me 2 radical 2 out of 2, and then we're going to have to divide this by 2, so I can just multiply it by 1/2, then I have to take the square root of this expression. So multiply the top by top and bottom by bottom, you will get 2 plus radical 2 out of 4, and then 2 plus radical 2 stays in the numerator, but square root of 4 in the denominator is going to go outside as 2. Now, this whole thing is for sine of 5 pi over 8. But if we remember the question, the angle given was a negative angle. And then using the properties of sine function, we know that whatever answer I get for sine 5 pi over 8, I have to put a negative in front of it and give them to this answer. So this will be the expected answer for this question. These questions, all extensions of the double angle and half angle formulas. This one was quite interesting here. It is an equation as cosine of 2 theta plus sine squared theta is equal to 3, and that's what it is given. So using the double angle formula, you needed to replace this portion in terms of sine and keep the sine one the same, combine the like terms, and reduce your equation to just in terms of sine. And then once you get sine squared theta is equal to 1/2, you take the square root of each side and you get two equations to think. Which are the angles whose sine value is equal to root 2 over 2? What are the angles whose sine value is equal to negative root 2 over 2? And you will give the answers accordingly. This is all I wanted to go over from section 6.6. Some of the questions are harder than the others, but they're all good practice. Please utilize the uh, example videos to manage your 6.6 homework. Thank you.